unified programming and executive managing. And we have a real-time applications services over the share organized and are not prepared as expected. And here they have examined the recent blockchain approaches, recognizing potential threats and the framework of the information interventions. In the motive of the in this study, we have security issues in the cloud computing system and data storage and different technology related to cryptography, and must be assured that shared data through the distributed environment. And this paper we have give the different security models by utilizing different encryption algorithm in a cloud computing system. We have the data losses are unavoidable in the various certifiable complex in the complex framework. And in this paper, we have a present review analysis of the different techniques of the data security in the cloud computing. We have various algorithms of the encryption algorithm for the data are used. And thank you, sir.
Thank you, Ashutosh, maybe for your presentation. I have two questions basically. Now, my first question is that, maybe your paper basically focus on the survey, yes or no?
Yes, sir.
Oh, can you tell me one concrete problem which you come across from this survey?
Sir, whenever I survey I find out the research paper and I study paper, then I find what are the problems can be occurs and identify the.
Yes, totally, I'm telling you studied it, that we listen your presentation. Yes. But I'm asking, can you tell me in a single line, sir, this can be a probable research problem about the cloud security like that?
Sir, data security.
Data security in the cloud is a big issue you are telling, yes?
Yes, sir. It is a big issue. Some users, unauthorized user can be accessed, or we have a.
Yes, understood. Now, my second question is that now, yes, in order to provide the security, we need to do a large number of encryption, decryption, like and so on. Okay.
Yes, sir.
Can you suggest which encryption, decryption algorithm is much more suitable for the cloud point of view?
Sir, in my research work, quantum key distribution, we use quantum key distributions, and we can develop with the help of blockchains.
No, blockchain is different, quantum is different actually. Okay, fine. My side is over.
Yes, sir.
Maybe others can ask question, if anyone.
Yeah, Ashutosh, I'm having one question. So, like in your entire survey paper, have you proposed any classification, like the techniques? Like, so there are many attribute-based encryption techniques.
You attribute-based encryptions.
No. Means, have you done any classification, like through which we can classify these algorithms and put it into different categories? Have you done that? Yes, Ashutosh? You're not audible.
Actually, he's not answering it. He may be disconnected.
Sorry, sir.
Okay. Yeah, yes.
Ashutosh, is it audible?
Yes, sir. It's audible.
Did you listen the question?
So there is a network issue also. Your voice is not clear.
Yeah. So, are you there now? Right now?
Yes, sir.
He's disconnected, sir.
Okay. So we can.
Yes.
We can continue.
Hello.
With second.
We can go for second, sir.
Yeah.
Okay. Let us move to the second.
Sir, before moving to the second slide, second presentation, I request all the session chairs to do the evaluation shared on the Google Forms.
Yes, yes, we are doing that. Don't worry. Okay.
Yes.
Yes.
Yeah.
The second paper is robust image watermarking using Android map and adaptive threshold value in LWT domain. Presentation by Manoj Kumar Pandey. Is he available?
Am I audible? Yes, yes.
Yes, you are audible. You share the screen.
Yes, yes, sure, sir.
Okay, as you already know that, probably you have the presentation time 10 to 12 minutes. Okay.
Okay.
Manoj Kumar, you are starting at 12:22. You should stop at 12:34 or 12:33. Okay.
Okay.
मैंने उनको बोल दिया कोई evaluation कर रहे हैं.
Hello, is my screen visible?
Yes, it is
Hello.
visible. It is visible. You can start.
Yeah.
Okay. So, Honorable Chairperson, dear faculty members, and all the research scholars, good afternoon to one and all. I am Manoj Kumar Pandey, PhD scholar from the Department of PSIT at Guru Gracia Center City, and I am doing my PhD under the guidance of Dr. Susma Jaiswal Madam. And I am here presenting a paper which is entitled Robust Image Watermarking Using Enrolled Map and Adaptive Threshold Value in LWT domain. So, these are the table of content, introduction, literature survey, significant of proposed work, methodology, which is basically making an extraction of watermark from the image, results, conclusion, references. Okay. So as we all know, this is the introduction. As we all know, that the watermarking is a process of adding any kind of specific text or image or signal in a cover image in order to reveal or check the identity whenever it is needed. And it is one of the most effective techniques for hiding the data information. And here in our proposed work, we have applied keys and enrolled cat map for increasing the security level. And here I have used the LWT transform. As we know, there are so many types of transform like DWT, DCT. So this is the LWT, that is lifting wavelet transform. It is a new transform in which all the data are presented in integer rather than the decimal point, and are all the coefficient. So, and it is also very preferred over conventional wavelet because of its energy compaction property. So therefore, we have utilized or used this LWT for our this research work. And here the adaptive threshold value is used for watermark extraction. That is a binary watermark, which is 0 and 1 only. And when we have checked the PSN, so it is giving 39 dB approx in case of no tag. So these are my literature survey. Here I have included 4 papers. That is, one is they run RS and all, and so they have developed a watermarking using DWT and wavelet tree. And here the cover size, the size of image and watermark is 512 into 512, and the watermark size is 2 into 16, which is 512 width. And images used are the Lina image, Pepper, Godil images. So here the problem is that this method is not very good or robust against the JPG compression, especially with the higher compression ratio. And again, the Verma ESETL have proposed a method in 2015, and here they have utilized the LW transform, and LST subband is utilized. Subband is a area where we can utilize for the embedding purpose. So this is for subband. And again, the same size of cover image and watermark image is considered for the research purpose. And here also this method underperform in case of the average filtering and salt and pepper noise. And again, in 2020, Islam and ETL have proposed a method which is based on machine learning method. And again, the same Lina, Mendel, paper, etc. All these basic images have been utilized for the research purpose. And in 2015 Verma VSCTL have utilized LWT and CST transform form for the implementation of watermark. So this is a literature survey. And now let's move on to the significance of the proposed work. Am I audible? Hello?
Yes, you are audible. Continue. Continue.
Okay. Thank you, sir. This is the significance of proposed work. So as the digital data is growing day by day, so there is a need of algorithm which can provide better security against the intentional and non-intentional attack. And security is one of the good or important aspect in every aspect of life. Therefore, it is very important to introduce a scheme which can fulfill all these requirements. And this is a blind watermark scheme, so it does not require original cover image or watermark image because it is a blind, and it provides good robustness as compared to other similar methods. This is the methodology. So here we have what we have done. Let me very brief that in cover we have taken the grayscale image, cover image. So we have decomposed the cover image in up to third level using LWT, and the size of cover image is 512 into 512, and HLC subband is obtained for the watermark embedding. And once the embedding is done, the different attack is applied on the watermark image in order to check the robustness. Robustness means how our algorithm performs in against the various attack, that is known as the robustness. And for the watermark extraction, watermark image is decomposed up to third level, like embedding purpose, and the reverse is done for extracting the watermark. But here we have used adaptive threshold value for getting our watermark image. So this is the watermark embedding procedure as the image shown. Here the watermark cover image of size 512 and 512 is decomposing LWT. HLC subband is obtained, and HLC subband is composed of 64 into 64 blocks, and again the 1024 blocks is obtained, which each block of size 2 into 2. And when the coefficient is shuffled in a key called T1, and then the block is shuffled for increasing the security of the system. And then blocks are identified for embedding. Here in the block identification method, we have divided the entire block into two. That is an important region and non-important region. In important region, we will embed the watermark, and non-important region will be left as it is for improving security. Here the watermark of size 16 into 32 is first scrambled using Android map, and then the quantization is done in order to do the watermarking, and then inverse lifting Euler transform is performed to get the watermark image. This is here we have used CD minimum and CD max in order to partition the blocks in important region and non-important region. Here based on a threshold. So threshold value is nothing. It is a value randomly taken for dividing the blocks. Okay, but the thresholding value has been taken in such a way that it balanced between the robustness and imperceptibility, because one of the most important challenges is to maintain the balance between these two terms, that is robustness and imperceptibility of the watermark image. So this is the average coefficient difference. How we have calculated is the formula is sigma is equal to, that is for all here the NB is nothing but it is a total number of blocks selected for watermark embedding out of from the NR from the important region. And here if the watermark bit is 1, modifying the coefficient using equation number 6, and if the watermark bit is 0, the modifying it is equation number 7. So basically for watermark bit we are not doing anything, we are just left as it is. But for watermark bit 1, we are again checking the condition that if CD max, that is a difference of coefficient, each coefficient where we are embedding the watermark, if it is less than the max of the sigma and the selected threshold, then we will add threshold value to the current coefficient, and if it is not, then we will subtract the CD max from the coefficient. And this is the threshold and embedding strength selection. How we are selecting the threshold. So as I already discussed that threshold value set in such a way that it gives a balance between the robustness, that is NC.
Manoj, you have only 2
NC.
minutes left. Please do it fast.
Okay, sir. Normalized coefficient and PSNR. So for T is equal to 38 and embedding it alpha is equal to 0.4, we are getting the good result, and which is shown in the further slide. And we have also observed that for applying threshold level 38, the IR blocks for IR we are getting is good. And so this is the watermark section. It is just reverse of the embedding process. Here we have used adaptive threshold value method for getting the watermark image. We getting the watermark in order to check the entity. This is the watermark section. Here the gamma is equal to gamma represent adaptive threshold value for used for watermark. And watermark bit is extracted using the equation number 9. Watermark bit is equal to 1 if CD max is greater than equal to minimum of gamma and threshold value, otherwise it is 0. So this is the result and discussion. In figure 3 we can see the original Lina image, and A in B we can see the original watermark image, and C we can see the watermark image is PSNR is equal 38.98 dB, which is for T is equal to 38 and alpha is equal to 0.4. And this is the D extracted watermark with NC is equal to 1 and bit rate is equal to 0. And this is the 2 other images which we have used for the experimental purpose. So this is the PSNR, NC and beta rate calculation. So here we have these 3 terms for calculation of the results. This is the result. Figure 5 shows the PSNR value of image, Lina, Mandel, and Peppers, and with comparison with the other literature. And here we have seen that for different threshold value, we are getting a different PSNR. That, like for T is equal to 45, we are getting PSNR of around 37 for the image Lina, likewise. And one we can see that as we increase the threshold value, the PSNR is getting decreased. And this is the performance comparison against JPG and medium filter attack. Here we have compared with 5 literature, and for this is for Lina image. For JPG 10, as we can see that we are getting the NC value of 0.97 and bit rate is 0.013. And likewise for JPG compression rate ratio 20, we are getting 0.98. Likewise for median filter, we are getting it 0.589. And for the cropping attack, salt and pepper, and speckle noise and histogram equalization, we are getting.
Can you conclude?
Yes, sir. Sure, sir.
Yes, please conclude.
We are getting this result.
Yes.
Yes, sir. And this is the bit error rate, and we are getting we compared with literature to second and third. So time taken is also taken here, the comparison. And conclusion is that that the proposed blind watermarking method is very robust, and inversity is also taken care in the system, and adequate PSNR approx 39 dB and good NC value ensure that proposed method is good enough to resist against some common attack which we have mentioned over there. And one limitation of proposed method is that it will not perform well in case of cropping and medium filter attack. And in future, machine learning method like SVM can be used for improving the result.
Yes, Manoj Kumar.
These are the references.
Yes. Thank you for thank you for your presentation. I have 2 questions. In your proposed solution, you have calculated the time. Okay. How did you calculate the time?
Sorry, sir.
In your proposed solution, in your result analysis, somewhere you mentioned you calculated the time. How did you calculate the time? What is the formula?
Time is yes, sir. Actually, sir, I have used MATLAB for that, and in MATLAB there is one function that is for time evaluation. So for the selected block, we can see the time of execution, what is taking some seconds. So in the same, I have
is it time for the watermarking of your image or what?
So it is for embedding purpose, and left one, and right one is for extraction purpose, sir.
Okay. Now my second question. Can you tell me the single line difference between your work and the recent literature?
Sir, actually in recent literature nowadays there are too much the researcher working on, sir, working on machine learning methods, sir, but this is not machine learning. It's a basic actually for the research I have started. So when I have started, so I have started from base. So I have implemented this without using any machine learning method, and it is also giving good accuracy. Therefore, sir,
Okay,
this is
fine.
the
My
main
side is completed.
difference. Sir.
Okay, thank you.
Thank you, sir.
My side is completed. Others can ask.
Okay. Hello.
Yes, sir.
Yeah, you are considered only the parameters like only PSNR and other any other parameters you considered for comparison?
Sir, yes, sir, I have considered PSNR, NC, and beta error rate, sir. PSNR,
Okay.
NC, normalized coefficient, and beta rate, sir. Beta rate is also considered for the research, sir.
I think some other standard parameters also you can consider, no?
Sir, like, sir.
No, you may consider another standard parameters available.
Okay, sir. Okay,
Is it
yes, sir.
no?
There's a yes, sir. There's
Okay.
also sir, that like mean root square error.
Yes, that's what. Hmm.
Sure, sir.
Okay.
Sure, I will do
Okay.
that.
Okay. Thank you.
Okay, thank you so much, sir.
Yeah. So I'm having one question that what will happen if you'll increase the size of marking? Like you have taken some watermarking size, right?
Yes, sir.
So in your proposed algorithm, what will happen if I will increase the size, watermarking size?
Sir, if we'll increase the size of watermark system, sir, then we have to select or choose the threshold in such a way that all the size of watermark can be embedded can be embedded in such a way that suppose here we have taken 1632, that is 512 bit is total embedding, and if we double the bit, so threshold must be chosen in such a way that we can embed all the bit in the image.
Okay, so according to you, what will be the optimal size of watermarking?
Sir, I think it can be increased up to such level, or it can be decreased to some levels, sir. Not because the size, because the total block that we are using is only 1024, and we are just taking watermark bit is 512. That is just half, sir. It is just half of the total bit considered for the watermark embedding, sir.
Okay, thank you.
Okay, thank you so much, sir. Can I leave?
Yes, you can leave.
Thank you so much. Thank you so much, sir.
Yes, next title of the paper is Robust Pipeline for Detection of Adversarial Image by Ankit, by Mr. Ankit. Is he available for presentation?
Yes, sir, I'm here.
Yes, please share the screen.
Host has disabled the participant screen sharing.
Can you make him for the presenter?
Yes, and
Yeah.
you can start.
Yeah,
And as we
thank
have
you.
very limited time, so please do it a little bit more pace.
Yeah, sure.
You have just 12 minutes time, please. Okay, you stop it after 12 minutes, okay?
Sure. My screen is visible.
Yes, visible. Please start.
Yeah. So good afternoon, everyone. The paper title which we are going to present is Robust Pipeline for Detecting Adversarial Images. We are a group of three authors who are working on this and guided by Professor Dr. Pooja Jain from IIIT Nagpur. So I'll cover the following topics on the presentation. And so the idea of the presentation is that these days neural networks are given a too much hype, and it's considered their use case in each and every field, like from self-drive cars to artificial intelligence, chat bots and other ways. But actually these neural networks are pretty easily, they can be easily fooled. When we give images to them to have a classifier on them, to basically build a classifier on them, the classifiers can fail if the some kind of extra carefully crafted patches or some kind of noise is added to that image. These noises are known as adversarial perturbations. When some kind of noise is added to that image, these images are the attacked images, and they can make sure that the image classifier that is means already the state of the art classifier, even it will not be able to predict the actual real class. So this is a small example in which from the ImageNet, it's an image of a panda, and some noise is calculated using a generative based model, and with a given factor of which is 0.007 here, that is known as the epsilon. This noise is superimposed on the panda image, and as you can see, the model which was detecting the image as panda, now it's predicting it as gibbon. So and the main idea what we are trying to solve is that there are different ways nowadays in which different attack mechanisms are there to fool the neural networks. So what Carlini has concluded in the previous research work that adversarial samples are really hard to detect, and some significant work has been done to make sure that our adversarial samples are being detected. So our focus is that we are trying to build a model which can act as a first line of defense. So whenever, let's say, you are doing your eKYC system, so you need to do a profile match or a particular image match. So if an adversarial image is passed on that, so it should detect that image is adversarial and that particular image should not be accepted. So that will be removed beforehand itself. So it can act as a first line of defense. And the mechanism which we have proposed is focusing on the changes of the image rather than identifying the adversarial parts of the image. So the previous work done on this field means everyone tried in some different ways. So the first paper which is mentioned is having its own sub network as a detector network that tries to detect the kind of attack, but it is not able to generalize all the kind of attacks. The second mechanism focuses on the defensive distillation that presents a concept of distillation in which you have to train your model in such a way that it is not able to that it is not fooled by the adversarial samples. But actually, in the issue is that the current state of the architectures, all the architectures does not perform well after they are done defensive distillation. So, and you need to fine tune each and every model. And the previous state of the art architecture, which is working as a binary classifier on top of to identify whether it's a original image or a attacked image. Its accuracy is 0.99, but it is very sensitive to the epsilon value, which I've shown you before. If the epsilon value is high, means if the noise is considerably high, then it's able to identify whether the image is attacked or not. And if the epsilon value is very low, then the accuracy drops drastically. So on the background work, I'll talk about the different kind of attacks, which is nowadays people are using. The first one is the fast gradient sign method, in which the model gradient method is used to generate the noise, and that noise is superimposed on the original image. And you can see the three kind of images with different epsilon values. As the epsilon value keep on increasing, the image is more distorted and the noise is very evident. Hence, it's easy for the models also to identify whether it's an adversarial sample. And models won't be able to identify these images as a dog breed. So it's a very simple, intuitive method, but it's very weak kind of attack because the noise is very evident. And the next, it's a PGD attack. That is a very iterative based attack in which uh, we try to keep on changing the images by a very small base gradient method, and the number of steps are infinite, and it keeps on trying to change the image until the model is successfully fooled by that image. So this is the one of the most strongest based approach to fool an image. And the most significant work means nowadays, which is used as a patch based attack. These attacks are used in a way that for every image classifier in an image, they will only belong to the image will belong to a particular class only. So taking that idea into mind, what it does is that it creates a patch of a particular target class. And since the model will try to focus on that particular feature itself, and it will automatically, instead of detecting a tractor, it will be detecting it as a toaster because of the patch which is superimposed on that. So the same patch can be superimposed on different locations on the different kind of images to basically fool it and make it a target based attack up to a particular class. So the data set which we use to test our model and to check everything was the ImageNet validation set. It was having a 10,000 classes of different images sizes. So overall, the size of the dataset was 50,000 images. And till now, all the scene and SOTA architectures all are trained on this particular dataset only. The pipeline is pretty straightforward. What we do, first of all, we use all the pre-trained architectures on the original image validation set and what their accuracy and how much they're performing on that validation set. Then we created a database of all the adversarial attacked images that we created from this dataset only. We performed different kind of attacks on top of these ImageNet images itself. I showed you the three kind of attacks which we applied on these images. So we created another database of that. Then we tested the SOTA models and we observed how low the accuracy of those SOTA models were on the adversarially attacked images. At the end, we built a network that was able to generate the manipulations map out of the image and highlight the area which was basically on which the changes were done. And at the end, we used those manipulation maps of the original and the attacked image and trained a binary classifier on top of that. And that binary classifier can now act as an independent first line of defense to basically remove all the adversarial attacked images coming to a particular model. So the methodology was this originally attacked image. We used a mantra-net based architecture that is a manipulation tracking network that observes which all areas are perturbed in this image. So out of this, we got the manipulation map. And in this patch base, which is attack is there's another manipulation map which we got. These two manipulation maps are at the end used to basically train the binary classifier. And the binary classifier is then able to give a decision whether the map is from the original image or attacked image. And with that, we are able to identify whether that image is original or attacked. So for the binary classifier, we use MobileNet v2 to keep it as light as possible because the images are going to next model also said the time required for that should be pretty low. And these are our samples on the tagged images. You can see the English printer on the original image. And when we applied FGSM attack, it was predicting as a Saint Bernard. And when we applied a PGD attack on it, it was predicting it as Tibetan Mastiff. So this way, for the same thing, it can have different results on the basis of different kind of attacks. These are some samples of the patch-based attack which you perform. And also, like, it's possible that people use Photoshop also. Suppose I have my Aadhaar card, people can swap their photos also, and that can also be another issue which we are tackling that also by the same pipeline itself. So this is the accuracy of the base model on the original samples. Accuracy of the SOTA architectures of VGG, MobileNet, ResNet, Inception on the original adversarial samples, that is in the range of 70s to 80s. But then when we tested it on the validation set, which we created of our database on the attacked images validation set, then the accuracy dropped from 70s to 10s and 15. So that is the problem which we understood, that these models are easily getting attacked on this, and it's pretty easy to fool them. So when we trained a binary classifier, we were able to Anubha, can you please mute yourself? Yeah. And the accuracy of our binary classifier was 98.6% as compared to the SOTA, which is 99.9. But SOTA was highly sensitive to the epsilon value. When the epsilon value is reduced from less than 0.03, the SOTA falls less than 0.05% accuracy, but our accuracy remains constant since it does not focus on the change. Means it focuses more on the changes of the image rather than identifying the noise itself.
Ankit, you have a last 1 minute. Okay.
Yeah. Coming to conclusion only. So we introduce a very simple method to detect spoofed images that can be irrespective of the type of method, and it can generalize into different kind of attacks. And moreover, these can be also used to identify attacks such as which are done by Photoshops and other methods. And to further improve our model, we can also like have, there's one more kind of attack that is single pixel attack that we are unable to overcome, but there can be different morphological operations which can be used to identify the single pixel attack, which is the best attack till date. So these are some of the references which we have used. So I'm open to any questions.
Yes, Ankit, I have two basic questions. Generally, when you go for these adversarial samples and adversarial models, there are two approaches. One is white box approach and black box approach. Okay, in your case, which approach did you consider?
We considered both the approaches. So FGSM attack is a white box approach in which the model gradient is provided, and then only FGSM attack can be applied. But the PGD is an iterative based approach, and that belongs to a black box approach.
I hope
so we incorporated multiple kind of.
I hope you know the clear difference between the white box and black box. Okay.
Yes.
If not, please revisit once again and look into that. That is your first question. And my second question, as you mentioned in the slide number 17, by changing the adversarial samples, your accuracy got reduced from 71 to 10.4. Yes?
Yeah.
So how to prevent this? How to overcome this problem?
Yeah. So actually it was, we use the VGG16. Let's say we use the actual VGG16 weights which are provided by the ImageNet only. So its accuracy on the original sample was 71.3.
No, my question is, yes, means whatever the VGG16 model can easily perform at it. It is very clear from this table. Yes or no?
Yeah.
Okay. Now my question, how to prevent this?
Yeah. So if any image, let's say, yeah. So if any adversarial image will come and it will go through our binary detector, a binary detector will use the MantraNet approach and will get the map, and it will automatically say that image is attacked. And instead of passing it to VGG16, we will automatically say it's attacked and we will remove that image. So our approach is not to like make the model better, but we are removing those images and acting as a first line of defense.
Okay, fine. Okay, my side is over. Others can ask us.
Hello. Hello. Am I audible?
Hello.
Yes, you are audible.
Yeah.
Yes. Yeah. So what is the limitations actually in this method?
The major limitation is nowadays there's a famous attack which is single pixel attack is observed. So that single pixel attack uses a way in which only a single pixel of that entire image is changed, and with that the model performance is drastically reduced. So that kind of attack we are unable to process. That is one of the major drawbacks of our approach.
Okay, any other question from others? Okay, if there is no questions, let us proceed to the next paper.
Thank you.
Yes, thank you. Thank you, Ankit. The next paper is paper ID is 260, SIAM LBP, exploiting the texture discrepancies for deep fake detection. Is anyone is present?
Yes, sir, I am present.
Yes. Can you make?
Sir, I'm to share. Okay.
Yes, he is making to you presented. Yes, now time is 12:55. You have to stop your presentation in 12 minutes, okay?
Okay, sir.
Yes.
My name is Steffi Kingra. I am a research scholar from UIT Department of Punjab University, Chandigarh. So I am going to present this paper on SIAM LBP, where we have proposed a new model for deepfake detection. So in this paper, I am going to cover this content. So from the very basic of deepfake forgery has come from the digital video forensics domain, which deals with the prevention and detection of manipulations performed in a video. And any kind of manipulation performed in a video is termed as video forgery, which can be performed either at intra-frame level or inter-frame level. On various levels, video forgery can be of any type, So we are dealing with deepfake forgery, which is the most recent and is able to produce more realistic fake content. So deepfake forgery came with the concept of artificial intelligence, with the indulgence of artificial intelligence into video forgery, which is generated using deep neural network, where a victim can be made to say or do anything in a particular video. This artificial intelligence has provided more realism to the fake content, like we can see in this screenshot here. Her Obama Barack videos is lip synced version, where he was purported to say things that were actually said by another person, Jordan Peele here. Deepfakes also came to India by a viral deepfake video of BJP leader Manoj Tiwari, where he was seen conveying a message in two different languages, like in Haryanvi and English. That was actually a deepfake video generated from another video where he was conveying a very different message. So we can see that there are positive implications of deepfakes also, but negative implications of it cannot be neglected. So there is a need to detect deepfakes because it has made it difficult to trust the video content, which can be used in various court proceedings, which can be used to provide evidence in some legal matters. It has made it difficult to trust digital videos because AI has provided more realism to the deepfake content. There are various user-friendly applications also available, like Reflect, FaceApp, FakeApp, through which a naive user can easily create deepfakes. Women politicians are greatly affected by deepfake due to various cases of fake porn and fake political campaigning circulated in the society. If any wrong video, if any misinformation is spread on social media, reputation of everyone can be easily destroyed. So there is a need to make efficient technique for deepfake detection. These are the papers that have proposed some new techniques for deepfake detection, but most of it has some limitations. Like most of the papers utilized a blind approach for deepfake detection. Usually what it does, they trained a very complex deep network on very large amount of data for automatic extraction of deepfake artifacts. But such techniques are not generalizable and may tend to overfitting of the on the training data. Some of the paper focuses on GAN generated artifact only, which are able to hide in advanced deepfakes. So our technique, the technique proposed in this paper, has also focused on one of the GAN generated inconsistency, that is texture based inconsistency. Because some of the GAN models, due to mix and match of source and target images or due to their inefficient training, produce some texture irregularity around a deepfaked face, which can be easily captured through a deep learning model. Our model compares the texture feature of deepfaked face and original face of the same person using a Siamese network. Let me show you some examples. These are the real faces of two persons along with their texture description. This is the deepfake version of first person. This is the face wrapped version of first person. So we can see here in the texture, there is some consistency around the lip area and around eye area in deepfake version of this person. But in case of lip synced video, these are the lip synced versions of second person. In case of lip syncs, only lip movements are manipulated. So some texture inconsistencies are not available, but our model is able to capture through texture. Our model is able to capture lip sync deepfakes also. So coming to the proposed methodology, the very first step is to compute LBP for texture artifacts. So let me show you an example of this. So suppose this is a whole image. We have used a particular block here. LBP is computed by comparing the center pixel of a block with the neighboring pixels. So if we compare this 10 with 12, which is higher than 10, it will generate a binary value 1. If it is compared with 11, which is also higher than 10, it will generate a binary value 1. After that, if 10 is compared with 9, which is less than 10, it will generate a binary value 0. So we can see it will, for all the 8 neighbors, it will generate a 8-bit sequence. This 8-bit sequence is converted into a decimal value, which replaces the center pixel through which all the elements are compared. So this is a procedure to compute LBP of a particular block. In this way, all the pixels are considered as center pixel and an LBP coded image is generated in step 1. So step 2 is the classification. So for classification, we have proposed a new model based on Siamese network, where a base model is ResNet 18. This Siamese network takes 2 inputs and compares the similarities or dissimilarities between the texture features of those inputs. So to extract features from ResNet 18, that is the base model, we have popped off the last 2 layers and employed pooling layer, dropout layer, and 2 fully connected layers after that. These fully connected layers give us 5 and 2 dimensional embeddings, which are concatenated to compute a 1024 dimensional embedding, which is then fed into another fully connected layer for binary classification. At the end, the sigmoid activation is performed for classification of deepfake faces. So summarizing the whole framework, first step is the pre-processing, where we have extracted faces using MTCNN classifier. And we have computed texture using local binary pattern, that is LBP. After that, Siamese model is proposed. 2 inputs are given to 2 base models in dual stream. These inputs are 2 types of inputs are given, like in a pair, if both are real images of same person, then the label is 0 or real. If in a pair, one is the real image of subject A, another is a fake image of subject A, then the label is fake. So training is done on this idea. After extracting embedding from the base model, a classification phase is there, which concatenate the embeddings and then perform classification using 2 dense layers and sigmoid activation. So this is the whole methodology. These are the hyperparameters that we have selected after certain range of experiments. The batch size is 16 and a learning rate of 10⁻⁻⁴. Adam optimizer. Learning rate is decayed with a factor of 0.005 after every 10 epochs. We have tested our approach on face forensics dataset, which is a widely available open source dataset. Face forensics dataset contain 4 types of manipulated videos: deepfake, face swap, face-to-face, and neural texture, 2 of which are face swapped version and another 2 are lip-synced version. So our model has provided efficient results on all 4. Like we can see on deepfake videos in the first category, our model has provided 99% accuracy. On highly compressed videos also, our model has provided 86% accuracy on deepfake content. So these are the lip-synced results. On lip-synced versions also, our model has provided 96% and 94% accuracy. After that, we evaluated it on CELIB-DF dataset, on which we have got 91% accuracy. We have also developed a new dataset based on some user-friendly applications available for creating deepfakes. So these are the sample pictures created using face app and first order motion model. We have also got efficient accuracy on these datasets also. So this is the AUC ROC curves of results on face forensics dataset for different manipulation types and for different compression factors. This is a generalizability. We have also tested the generalizability of proposed technique from one manipulation type to another. Here we have noticed that if a model is trained on lip-synced versions like anti videos, it has provided a good accuracy on facially manipulated videos also.
You have
Okay,
last.
sir. Okay. It has provided a good accuracy on face swap videos also. Because when a model is trained on lip sync versions, only lip area is manipulated, and a model has learned very efficient features so that it can perform well on face swap videos also. This is the comparison with state of art on different compression levels. This is the comparison with state of art on SALIP DF dataset. So our model has outperformed several state of art techniques. So in conclusion, we can say that due to rapid advancement in deepfake generation mechanisms, it has increased the threat of deepfaking by defaming a common man or by sharing misinformation in the society. So this cat and mouse race is a never-ending problem. With every deepfake generation mechanisms, we have to develop a new detection mechanism also, so that we can advance it. So we have proposed a new model CM-LBP for deepfake detection, which perform texture-based comparison of deepfake face with original face using CMS network. We have got 99% and 91% accuracy on deepfake videos of different data sets. So in future, this CM-LBP can be used with the different base models. Like we have used ResNet 18 here, different base models can be used in future to test, to evaluate the technique. Thank you, sir. If any questions?
Yes, thank you for your presentation. I have two questions basically. Can you go back to the some kind of result comparison is there? No? Yes, wait, yeah. Now this 4 to 5 approaches, and you
Yes,
compared
sir.
with your proposed approach. My
Yes.
basic question is that, is this 4 approaches the data set used, and in your proposed approach data set is used same or different?
Yes, sir. Yes, sir. We have selected those approaches for comparison, which have selected the same data set for evaluation.
Very good. Now, suppose if I see FCNN, there is a accuracy 66.50. Okay.
Yes, sir.
And whereas in your case, 91.5.
Yes,
Can you
sir.
tell me why this much improvement is there in your solution?
Sir, because they have utilized some kind of features, like they have utilized frequency features for classification. We have utilized texture-based features. So the main difference is in that only.
Means you are saying that basically you have done the best feature selection method. That's why your solution is performing.
So best feature also, we have also proposed a new model. They have utilized only CNN-based model. CNN layers are there. We have compared it using a CMS network.
Okay. 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 Fine. Okay. Now, for example, if this solution is really fruitful, okay, how you want to bring? You want to bring this as a tool, or what you want to bring as this as a software?
Sir, actually, we are working on multiple techniques right now.
Okay.
So we want to use multiple techniques for any kind of deep fakes, because only one technique cannot provide efficient results on all kind of deep fakes. So we are trying to combine multiple techniques, and then we'll go on with a tool also.
But my opinion, in this deep fake, bringing the robust solution is always challenging.
Yes, sir. Yes.
Okay. Now, my opinion, suppose as you are a PhD student.
Yes, sir.
Yes. Now you just make a research objective how to build the robust solution, so that maybe sometimes your accuracy is less, but you are looking forward the robustness. Accuracy definitely is a kind of, like you said, it is a cat and race.
Yes,
okay?
sir. Yes.
Somebody says that my accuracy is more, yours says that, but nobody is looking the robust side. Maybe my opinion, you can look into that. Okay.
Okay, sir. Thank you, sir.
Any other questions from anyone?
I think in the reference section, you have included the website address links, some links. I think it's not, better to put some, papers, recent papers.
Sir, actually, I have utilized, I have shown you some screenshots of videos of deepfake examples. I have written those links here.
Generally, what's our suggestion? When you come to technical paper context, it should be technical papers.
Okay, okay.
99.9% you should not give any YouTube links. That is not any peer reviewed.
Okay, sir.
Okay, we
Actually,
always
they were not published. I have also seen the papers, but they were not published. So I have
no,
just
no.
given them.
As a research scholar, you should always refer the peer-reviewed journals, peer-reviewed conference.
Okay, okay. I'm sorry for this.
Okay, thank you. Good.
Thank you, sir.
Okay, thank you.
Thank you.
Okay, the next paper is paper ID is 425. Vehicle theft identification using machine learning and OCR by Priyam Roy.
Yes, sir.
Yes. Are you there?
Yes, sir. I'm here.
Yes. Can you make him presenter? Yes, you are
Yes, sir, he is
starting at,
present.
yes, your screen is visible. Please, yes, you are starting at
Okay,
111. You should stop after 12 minutes, okay? 123,
okay,
you
sure,
have to
sir.
stop. Okay.
Yes, sir. So good afternoon, everyone. I'm Priyam. I'm a graduation student from DIT University, Dehradun. So we are going to talk about the research paper ID 425, vehicular theft identification using machine learning and optical character recognition. So these are the things that we're going to talk about: the background literature survey, description, methodology, results and discussion, conclusion, and references. So let's talk about the whole background of the project. So in India, we see that a lot of vehicular thefts are happening. We uh, we may know someone close to us that has gone something through something like that, where the vehicle may or may not have been gotten stolen. So to ensure these things happen less around the major cities like Delhi, Bangalore, Mumbai, Lucknow, and all these major cities, we are trying to develop a way where, in most of the cases, we have found that the vehicle that are stolen from that particular city is not used as a stolen vehicle in that particular city itself. It's either transported somewhere else or just scrapped for parts. So we are trying. What we are trying to do here is in the duration of the transportation, uh, it is mostly seen that highways or some other expressways are used to get out of the city. So in that part, on the checkpost or the toll nakas, we have the camera, the hardware setup already installed that they use for their CCTV footaging, and also for taking screenshot of the number plates for their billing purposes. So what we are trying to do is use those particular screenshots, and in the given time, the vehicle that is passing through that toll naka, we can capture the number plate of the vehicle and convert that image into a string format, and then in the backend we can check in the database for a theft status or not. So how we are proposing to do this is, first we can talk about the literature survey. uh, we have seen a lot of methods where automatic toll collection systems are also used to do this concept of detecting the number plate. And most of the toll are having SD cams, and they also use OCR for the billing system. If any if you read the bill of any toll naka, you get the number plate of your vehicle printed itself. So that is done automatically. And all these research works we have considered, most of them are using Tesseract engine and OpenCV for image pre-processing. So we also are using OpenCV for the image pre-processing. So let's talk about the problem description. So again, we are talking about the theft status of the vehicle. So it is after the vehicle, these days vehicle are equipped with GPS and advanced tracking systems to track the vehicle down from for the theft status. But again, people are getting cleverer to disable those systems of the security system. So what we are trying to do is, anytime a vehicle passes from any checkpoint, we can just go through the number plate of the vehicle and check the data of that number plate in our servers to get it detect it as stolen or not. Also, we have maintained a database where sorry, a management system for the officials or the people at toll naka itself, where they can in real time update or delete or like update the status of the vehicle that they passed from there or not, and they can in real time delete if it has been reported or it has been recovered or something like that. So we also have a management system to counter that part. So let's talk about the methodology. First, we fetch the image from various sources. While the working of our project, what we did was we ourselves captured the images from our personal vehicles as well as vehicles from the traffic and all. And then after the acquisition of the image, first we need to convert the image to RGB. Because when we are using OpenCV, the image gets converted to BGR, so the color profiling is a little bit different. Then for OpenCV to work efficiently, we need to convert it to grayscale images that reduces a lot of color information so that the image size becomes less and it is easier to process and time saving. After we receive a grayscale images, we convert that particular grayscale image into canny edges. So in the process of canny edges, the edges of the images, like in our case, the number plate. So the edges of the words itself get highlighted as white, and anything other than the edges gets highlighted as black. So basically what we are trying to do is convert that particular image into a black and white image for easier processing. Then we apply a bilateral filter that sort of it removes the grainy, noisy things that also are detected as edges. In some cases, we had the vehicular grill that got detected as a part of image itself. So also maybe the road also dust particles and something like that. So we use a bilateral filter to clean out most of the image and try to keep only the part where the number plate is. After that, what we can do is apply contours. So contours can just clean out the edges. And last, we what we do is crop the image where the number plate exists by using bounding box method. After cropping the image, it is very clear. After cropping the image, it is very easy to convert that particular image to a string format using tesseract engine. And then when we get the string format, the data is then further used to check and uh, identify if there is a theft or not. So we can talk about the results of our project. So in case of simple words where U, P, something like these words that are very easy and simple to detect, the accuracy was pretty good of 100%. But in case of complex word like M that got recognized as W, or O, there was a confusion between O and 0. Also, the tesseract engine that we used was the latest version, but then too we had problems with the accuracy of the results. So what we are trying to do is crop the part with the number plate itself, only that particular rectangle which has the number plate, so we don't get any extra words out of logos or any extra characters out of other things in the background. So what we can do after identifying the string part from the number plate is that we have a management system where we can form a community where a end user whose vehicle may have got stolen can just open that system and update his initials and details about his stolen vehicle. Maybe maybe additional information that can help easily identify the vehicle, maybe the color of the vehicle, logo, and any other changes, brand, make, something like that. And that would be a easy way to just point out from the rest of the vehicles that even in case of the number plate is stolen, changed, and that is one of the most common things happening in India, that after getting the stolen the vehicle, the number plate is changed to some different number. So what we are trying to do here is let's say you have a white car with some particular number, and that number plate is changed to some other different car's number plate, and that is a fake. So what we are trying to do is, if a user has reported his stolen vehicle to be a white car with that number plate, and a fake number plate gets detected somewhere, and the color information is not syncing up, that fake number plate may be of a black car. So that would create a difference, that the points don't match. The plate should have been of a black car, not a white car. So that could be a determining factor, and that could raise a suspicion and help to figure out the theft status of that vehicle. So to provide a conclusion, we have designed a graphical user interface where we can upload a image captured by a camera. Then the whole thing is sent to a pre-processing engine and converted into a string format that can help identify the status of the vehicle. And the result is a bit effective than manually checking numbers, and like in a checkpoint, the police officials are there to manually check the each and every vehicle with its RC status and everything. So this is a bit effective way to do it, using the reading system of the number plate and then checking for the extra features of that car. So these are the references we used, and thank you for the presentation.
Yes, thank you, Priyam. I have two basic
Yes, sir.
questions.
Yes,
And
sir.
the basic questions related to the feasibility of your solution. Like
Yes,
as
sir.
you said in the conclusion, actually you would have started your problem with, okay, after
Yes,
stealing
sir.
the vehicle, they will change the number plate. How to solve is better,
Yes, sir.
my opinion. Because obvious, the moment somebody stolen your vehicle, they will keep the same number plate and roam in the city. That is 99.9% is not possible. Okay,
Sir,
my
what I
opinion.
was trying to
Yes,
no,
continue.
sir, that's what I was trying to say.
Hmm.
That in case of a stolen vehicle, no one is
Hmm.
gonna roam around in the city with that same vehicle.
Hmm.
The first tendency would be to get out of the city as soon as possible, right?
Agree, but
So what?
he will also move out the city with a different number plate. Generally,
Yes, sir.
that is the person who theft the vehicle is mentality. Maybe if you want to
Yes, sir.
extend the
Sir,
work, you can start that as your input point and work accordingly. That is a one suggestion from my side.
okay,
And second, as you
okay,
said,
thank you,
you
sir.
developed the GUI, these all, but you didn't show anything GUI in this particular work. Is it already part of paper, or you're going to do that in your future
Sir,
work?
part of paper, yes, sir, it is.
It is
But
already there.
we have,
Okay.
yes, sir, we forgot to mention in the PPT.
Okay. Second and third question. For example, to do
Yes, sir.
this, to develop any machine learning model or something. Yes, sir. Are you developing a machine learning model to detect or not?
No, sir, we are using already existing.
Agree. Now,
So
if
to
you're
extract the plate part,
agree,
but we are
means
doing the whole updating thing.
agree, but somewhere you are using some kind of machine learning model to do that. Yes, sir. No?
Yes,
Either
sir.
existing
Yes, sir.
or yes, sir. No? Now, generally,
Yes,
this
sir.
model required the large set of data set. Do you have anything? Or if you don't
Uh,
have, how you are going to collect it?
Sir, in the collection time when we were doing it ourselves, we
Hmm.
had a group of 4 people.
Hmm.
So what we did is we assigned around 50 images to each of them to locally collect from
Okay.
our personal vehicles as well as the vehicles in the traffic or parking or something like that.
Hmm. But
So
try
we are
to look
not
into that.
using a data.
Try
Yes,
to
sir,
look into
sure.
that. My big question is that big concern also, the related to the
Mhm.
feasibility of your solution. Okay.
Okay.
Okay. Thank you. Anyone
Thank you,
have any
sir.
question?
Yeah. So can you please point it out like about the novelty of your paper? Means what novel work you have done in this particular paper?
Uh, Sir, let's say what we are trying to do, we have a lot of papers that are focused on detecting a string from a image, right? Any image, be it a number plate or be it any other kind of image that has some words written on it. Let's say we have Google Lens and things like that. So that is a very general purpose use. What we are trying to do is take that specific use of that reading from an image thing and apply it into a number plate detection system, where we can detect the plate itself, and we have a database where we can keep on updating regularly. And also what earlier sir has asked me the question about changing the plate, I would like to answer that in a way that what we are trying to do is, let's say you have a plate with you have a white car with a specific plate number, and the thief take it and change it to a fake number.
Priyam,
Yes, sir.
please try to understand. Sir question is, what is a novelty? You can answer in a single line. Okay, na?
Yeah.
See, this what is not there in the existing. I did this. That's all in a single line.
Yeah, that's what
That's
what
all.
novel work you have done. Just in a single line.
Single line.
Sir, that would be to use it specifically for the theft detection for the number plate itself, not a general purpose.
Okay, so my second question is like you have considered, you have taken all those images. So have you taken images for like different environments? Like what if there will be any rainy day and you have to take that particular picture? Have you considered those images too?
Sir, we had a problem with this thing about the night images that were grainy and also not very clear. So we had issues with the night images in the night time.
Mhm.
About the rainy images, we didn't consider using conditions like rainy images, rainy day
Okay. So you
images.
can consider that in your future work because anything
Okay,
can
sure,
happen.
sir.
Yeah. Okay.
Yes.
No, I don't have any query.
Yes.
Both the session chairs have raised the questions and they gave the suggestions. So that may be incorporated into the help. Thank you.
Thank you, sir.
On behalf of NIT Raipur and organizing committee of the conference, I thank you all for sparing your valuable time as well as providing valuable feedback to the authors. It is kindly requested to all the session chairpersons to fill the Google Forms for evaluation so that we can evaluate the best paper award. And apart from all this, I also request all the session chairs and participants to turn on the camera for a quick screenshot. Okay, thank you, sir. Thank you so much. Thank you.
Thank you, sir. Thank you, Parmeshwari, sir. Thank you, Venkana, sir. Thank you, Mohit, sir.
Thank you.
For like
Thank
at
you.
such a short interval, you people showed an interest and accepted our invitation. And
Yeah, thank
since
you.
I like
It's our pleasure.
the schedule was so busy, we were like trying very hard from past 1 month to make this event realize, like to make this event happen. And absolutely, like I also want to thank the session chairs for their making the session very interactive, as well as I also like thank participation from the authors, those who have contributed and making this MISP 2022 be a grand success. Thank you, sir. Thank you.
Thank you. Thank you. All the best. Thank you.
Thank you.
Recording.